Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello, good morning or good afternoon, depending on where you are connecting from. Welcome to this online session, which is ensuring the safety of your PV plant with advanced SCADA systems. So, well, you know, as you saw in the video, we are recording this session, and we will definitely share the recording with you along with the presentations that are provided. Also, remember to keep up the tradition we have at ATA Insights of introducing yourself through the chat. So, you know, just let us know who you are and where you are connecting from. Yeah, so that's, you know, for housekeeping. So we'll start by asking each of the speakers to introduce themselves briefly, and then we'll start with the presentations. So, right, so, you know, I'll keep this image up so you know, so you can identify them clearly, but I'll ask the speakers to introduce themselves as I see them on the screen. So, Georgios, if you could please tell us briefly who you are.
Yes. Hi. Hello, everyone. First of all, thank you, ATA team, for inviting me on this webinar. And I want to thank also the participants that they are logged in. My name is Georgios Zavitsanos. I am working for Aqua Power in the project execution office, and I'm being responsible for the PV assets of the company under the execution phase. For those that haven't encountered Aqua Power before, Aqua Power is a power and water developer company. It's well established in the MENA region and India. The company develops and operates at the moment more than 43 gigawatt power projects, conventional and renewables, as well as base desalination water projects. At the moment, more than 6 million cubic meters per day. It's the current generation of water in the MENA region. And we're very proud of leading development through competitive bidding and putting into practice new innovations around the. Thank you.
Brilliant. Thank you, Georgios, for your introduction, and welcome to this online session. So, Óscar, could you please tell us briefly who you are, so everyone in the audience knows?
Oh, hello, everybody. Good morning or good afternoon, depending on where you are. I'm Óscar Cabrero. I'm the director of the control system and monitoring from PVH, and I'm representing PVH here to show up a new value proposal for these advanced SCADA systems for monitoring these photovoltaic plants.
Thank you very much, Óscar, and welcome to this online session. So, well, we'll get to see your presentation later on. But in the meantime, I'm going to ask Venkata to introduce himself. So, Venkata, please tell us a little bit about you, so we all know who you are.
Yeah, thank you, Carlos. So, hi everyone. Good afternoon and good morning to everybody. So, myself, Venkata Rambabu Pallagani. So, I am a senior project engineering manager, currently working for a Sudhir project, 1.5 gigawatt peak. And coming to our company, L&T Construction is an Indian company. And in that, we have a power transmission and distribution IC. So, this IC is going to take care of EPC jobs of transmission line, substations, renewables, and we have presence in India, Middle East, and Africa.
Great, thank you, Venkata, for your presentation, and you're very welcome to these online sessions. So I'm going to stop sharing my screen, and I'm going to give the floor to Georgios, who will give the opening presentation. So those of you who have been at our webinars before know that first we do a round of presentations, and then we answer questions that you send through the Q&A box. So start thinking of those questions, and yeah, we'll get to them after the presentation. So Georgios, I can see your screen. It looks full screen. It looks great. So over to you.
Thank you, Carlos. So today I want to share with the rest of our participants from the point of the developer, from the point of view of the developer, which are the key challenges when we are discussing about those interfaces between the SCADA system of a PV project and the tracking system of the same. Taking a first point of design phase, we all know today the market, how stressed it is due to the module prices and other situations that we have faced, overcoming the corona phase. And we have seen how this price competitiveness is forcing, is driving basically, including the SCADA systems and including the tracking system, to lower the prices, therefore lowering specs of the hardware selection. This unfortunately has an impact on those hardware systems being able to withstand the heat conditions, the environmental conditions that we have in the Middle East region, as well as in some cases we have experienced data traffic management undersizing, where we have seen systems failing because of the scale of the projects that we have today, where we're talking about 500 megawatts or 1 gigawatt or 2 gigawatt projects with huge amount of traffic that needs to be processed and flow on a daily basis, not being able to be managed due to the wrong hardware selection. In addition to that, and another driving of price competition is the breakdown of those supplies that are under network architecture of a PV project system. So it's a typical approach where we have seen a breakdown of various systems, but at the end of the day, they need to be interfacing, they need to be designed together to be broken down in different vendors. And therefore, we have seen those difficulties in the design as well as the overall system responsibility. The redundancy concept of a design is also a very important challenge, especially when we are discussing about the tracking system, where we see the loss of communication being vital over the SCADA that expose the system to wind events, but also is responsible for loss of generation. We have seen designs where either from the SCADA point of network architecture or from the tracker point of communication system design, there is an under-design of redundancy that has a huge impact from the developer point of view during the operation phase. Finally, the overall system interfacing and the distribution of responsibility of those design systems is something that, if mismanaged by respectful stakeholders of those projects, will lead to problems in the overall operation of the PV plant. First of all, the design phase due to the lack of accountability on those interfaces, and especially taking into consideration the latest innovations in the industry, where nowadays most of the developers of such utility scale projects are relying on cleaning the modules through automatic robotic cleaning system, what we call in this presentation ARCS as an abbreviation. And the interface between these three elements, the SCADA, the trackers, and the robotic cleaning system, in terms of monitoring, but also in terms of their operational philosophy, is a big challenge at the moment from the design phase, and as we will see later on in the other phases. During the execution phase, and as I said before, today the magnitude of those projects are in the scale of gigawatts, and unfortunately the time durations are not proportional to that. So therefore, the teams today are being challenged to perform those commissioning requirements within the same time duration. Therefore, it is vital that we need to see fast-track installation, but as well as fast-track commissioning of those systems. A thing that we have faced during COVID event, but also we're facing today due to this fast-track requirement, is the availability of those commissioning teams, and especially when we're discussing about a lot of different subsystems that has to do with the overall network communication, where those commissioning teams, they need to work around the clock. They have to coordinate seamlessly in order to bring tasks to achievement. This is a very challenging situation for the OEMs as well as for the overall project. The integration of those signals, and imagine that in this scale of projects we are discussing about 10 to 15 or 20,000 trackers, with each tracker having its own signal, besides left alone the rest of the systems of inverters, etc. So all this signal interference and communication between the tracker supplier communication system and the SCADA system, the collection of those signals, and putting now in the same box the robotic cleaning system that needs to be working, to be operating by passing above all those trackers in a row. All this interface is a huge challenge during the commissioning phase, where the system startup and the debugging of those systems, we have experienced a very time-consuming process of those that impacts significantly the commissioning phase, and especially when nowadays you rely on having those modules cleaned and ready to perform for the project to pass the commercial operation milestone. Yeah? So it is therefore vital today that we can have a tracker supplier system that can take under the umbrella full management of signals and the grouping of those signals in such a way that they can be utilized together with the robotic cleaning system in an efficient manner and in a fast manner during the execution phase. Going to the last but not least, operation and maintenance phase. Maybe some of those participants here today are part of operation teams where they have experienced themselves significant weaknesses when it comes to those HMI systems that are put in place for the tracking monitoring, besides the rest of the systems. But imagine again, as we said before, having to monitor, having to visualize for the operator thousands, dozens of thousands of strikers, their status, their monitoring, alarm systems, etc. This alarm list management as well of strikers and the hierarchy of those systems, whether we're talking about the controllers of a group of strikers or whether we're talking about individual striker controller units. The management of all this is a huge challenge. Unfortunately, we have seen SCADA suppliers not being ready or not being fully engaged in the early phase of the design and implementation of the project, with the result leaving a huge punch list to follow after the commercial operation date, struggle with the operation for the project. Similarly, the same applies for the maintenance and the records of those systems, as well as the availability calculation of the tracking system and its performance. There are no standards in the market on how to calculate this availability. Should you calculate it only during the day? Should you exclude the wind events? Should you exclude the downtimes? These are all up to project implementation. Finally, whenever you are using a tracker or you are using a group of trackers because of system or a network malfunction, you have generation losses. It's very important for any operator to be able to monitor and calculate and evaluate those losses depending on the expense. In addition to the future operation of trackers should be able to correspond to the weather forecast system in such a way that the operator of the plant will take a decision when is the right time to clean the plant, clean the modules, PV module of the plant, whether he's forecasting, for example, a high wind event, bring storm or not, whether it's going to be rain, whether it's going to be high humidity. All those factors are factors that take significant role in decision making of tracker operational management and with respect to the robotic cleaning system. Finally, again, one of the huge challenges that the future projects will have on the operation and maintenance phase is the operation, the integration and operation of the tracking system together with those automatic robotic systems, where a loss of communication will result to bridge disengagement between trackers that will require manual intervention on the field, a costly manual intervention on the field, or see situations where a mismanagement of signals, a mismanagement of one tracker being out of alignment test will result to a big failure or even worse, system damage failure. So taking all this into perspective, I think from the developer's point of view, trying to optimize the vendors, and in our case, it's not the more the better, it's the less the better. In terms of vendor interfaces and integration, is something that we see value on, and as well as having a tracker supplier, a tracker vendor, taking under his umbrella management of all those signals, the management of all the SCADA-related monitoring and controlling of the system. It's something that we see a merit, and therefore we endorse it and appreciate such effort. So thank you so much for giving me the time to talk about things.
Thank you, Georgios, for your presentation. So, well, as I mentioned, you can post your questions on the Q&A box, and then we'll get to them later. And now I'd like to give the floor to Venkata. So, Venkata, over to you.
Yeah, thank you, Carlos. Hope you are able to see my screen, right?
Yeah, I can see it now. Yeah.
Yeah. First of all, I thank Georgios. I think he's very well covered all the key challenges. In fact, even the challenges that I covered is similar to Georgios. Of course, without much further on, I thought I will touch upon who is our company and what is our portfolio. So we are from L&T Construction. As in today, we have a portfolio of 5.5 gigawatt peak solar projects that we are doing. And of course, we have 180 megawatt hour BESS. And we are also doing one of the world's largest solar project in Sudair, and that is in Kingdom of Saudi Arabia. It is around 1.15 megawatt peak. And I am the project engineering manager for that. Then moving on to the key challenges that we have faced as an EPC with tracker communication. As mentioned by Georgios, of course, the tracker availability and the loss in generation. So if you take a 1.8 gigawatt project, of course, you will have around 35,000 to 36,000 trackers. And while we are estimating generation, we assume that all these trackers are going to be with respect to the sun position that we determine for this location. But in actual case, it may not be the case. And if we are unable to track each tracker is not on the actual position of the sun, then there will be a loss in generation, which will in a way impact EPC, because EPC is having a guarantee to the developer. So that is one, I can say, one challenge that we faced. The other one is how many such trackers are connected to one controller or one PC. Again, so that means it is with respect to reliability and the troubleshoot. So this is the one key challenge that we have faced, because in case if it is controlled by one tracker or one PC, any problem with that PC, then we will not be knowing it, what is happening to those set of trackers, whether is it really performing or not performing, that we will not be knowing it. So that is one key challenge. Then when it comes to troubleshooting, so how we do not have any access to troubleshoot on the software. So we need to depend on the tracker vendor. And in case if tracker vendor is available on site, yes, it is very easy. But if it is not, then it is a problem. So what we are looking is something like a remote troubleshooting method. If that is available, that is going to solve this problem. Then, of course, frequent communication interfaces between different equipments, as suggested by Georgios. If you take any solar plant, we have a string monitoring boxes, we have a robot SCADA, we have a tracker SCADA. And the best part is all these three elements are communicating wireless. So it is obvious that we choose a robust communication, which will not have any interferences or less interferences with the other communication devices. And the second and the next one is the anemometer and metallurgical sensors. So why I'm touching upon this is, like Georgios mentioned, whenever there is a heavy wind conditions, we measure the data from the metallurgical sensors. And what happens, this tracker goes to stow position if the wind speed exceeds the design wind speed. So this is also a critical aspect, because if we read the metallurgical sensor in one direction and ask all our tracker to go to stow position, that is not the optimum operation methodology. So this is also a key challenge that we have faced. And of course, we have a lot of data, and we are also monitoring the data on the tracker communication. But today, we don't have any insights on the predictive maintenance. Like suppose from the data, if somebody can say that, okay, so-and-so block and so-and-so tracker, this is the time to do the predictive maintenance, then that will help us improving our plant performance, and thus we are generating revenue from the plant. So that's all from our side, and these are the key challenges. I'll leave my contact here. If you have any further questions, you can ask here or you can write to me. I'm happy to answer.
Thank you very much, Venkata, for your presentation. So, well, as you said, I encourage the those in the audience to send their questions through the Q&A box. I can see already a couple of questions. So, without further delay, I'd like to give the floor to Óscar Cabrero so he can start his presentation.
Hello, hello everybody. Thank you very much to Georgios and Venkata for the presentations. Let me share my screen. Is it okay? Okay, great. So we are going to present you the value proposition that PVH has been working on for the last time, which is Pro Insights, a SCADA product with which we believe are solving a lot of the pain points that our customers are having and are experiencing. So to give you a brief overview of the PVH control system and monitoring system, our solution is based on all the drive boxes, which are the tracker controllers themselves, which will communicate wirelessly with the gateways, which are those devices in the picture. Those wireless gateways will connect and will communicate all the information from the trackers to the T-box, which is the central controller of the PV plant. And all these communication, wireless communication, is a very long-range communication system, which means that there exists redundancy in terms of communication. So if there's a device that fails at any time, then all the devices connected, all the tracker controllers connected to such device will connect automatically, and all the network will readapt to the available devices. So in that time, there is redundancy in terms of communication. All that information will be managed by the T-box. The T-box, which is the central controller of the PV plant, will manage all this data to perform the control task, and also to send back to the SCADA system all the key information. The Pro Insights offers a very easy and very simple solution to monitor, to by cloud, all the PV plant, which is only one racked computer for all the PV plant. That means that there is only one device that needs to be installed in the O&M building or in the substation building, and with a direct connection to the T-box, it will retrieve all the data. It will be very easily commissioned, and will send that data to our cloud secure hosting. That RAD computer is the key device to perform what we call the T-box high availability, which is the secondary redundancy. Second redundancy that we have on our system. The first one was the communication redundancy, and also we are offering with the Pro Insights the T-box high availability, which is a virtual system that is continuously watching over T-box, and if whenever a T-box fails, it will instantly be created another instance in that RAD computer to keep on performing the control task, to give the time to the operator to replace the damaged device in the T-box, and then this virtual instance will be reset on the hardware T-box. Thanks to that edge RAD computer, we also perform the track availability calculation, which is an algorithm that we perform thanks to the integration of this SCADA system with the trackers. with the PVH trackers. That means that it is a whole software stack, algorithm stack that with which we can calculate very precisely the availability of all the tracking system. And it's also responsible for the store and forward functionality, which means that if there is any communication lost between the PV plant and the internet, then the data will be stored in that RAD computer, and then when the connection will be back, that information will be sent to the cloud again. So to summarize, the solution allows to have the real-time status and historical performance data of the PV plant. It also allows the monitoring of the availability of the tracking system. It gives the T-box high availability. It also allows to get notifications in real time of any alarm that may appear in any tracker or any device of the PV plant, of the tracking system. There is also an option to graph and analyze tracking system data and also create custom trending, apart from the default defined graphs. And the store and forward solution that I have already explained. There's also another functionality, which is the meteor forecast and local weather stations monitoring, which is something that we found that customers need, and this is something that we integrate by default in our solution. So we have prepared a case study in which we try to analyze what a traditional SCADA is composed by in terms of economic point of view, and what we are offering with ProInsights. So let's say that we have a PV plant in which a traditional SCADA would cost 105,000 euros. So more or less, there is the 70% of the signals and the cost associated to that traditional SCADA implementation is coming from the integration of the tracker signals. And the rest would come from the rest of the devices coming from other devices within the PV plants. What we're offering with ProInsights is a native integrated solution with our trackers, our solar trackers, and cloud system. That means that we can lower that 70% of the tracker impact to the proportion that we are showing right here, which in terms of euros per megawatt means that we are passing from 1,000 to 172 euros per megawatt. That means that the capex of the project would be, instead of 105, would be 40. Would be 40,000 euros, with all the features that we have already explained in the previous slide. Okay. So continuing with the analysis, and from the point of view of the investment, a traditional SCADA would for the tracker signals around 73,500 euros. There would, let's assume that there would be no year-by-year cost. So then the cost after 25 years would be this capex. With ProInsights, we're offering a very easy and quick to install solution, which means that the initial cost is going to be very low. And we're offering a cloud-based solution. That means that we can offer with all the services that are set by default with ProInsights will be 22.8 euros per megawatt per year. Okay. So that leads us to around 65,000 euros per every 25 years, which would be around a 10% off. So to sum up, we have all these, in a traditional SCADA, the impact of the tracker signals is going to be very high, and the impact of the tracker signals integration with our solution is going to be very low in terms of CAPEX. The features for the EPC point of view that are key is the remote, easy and quick, and with no cost involved installation. We also are offering a 2 years availability warranty, apart from the availability monitoring, and 2 years of service included with that basic package. And in terms of investment, the same analysis that we made in the previous slide, with all the features that we have already commented. So, what is the impact of the availability of the tracking system in a PV plant? So let's consider that we have a solar plant with a specific performance of 2,037 kilowatts hour per kilowatt peak. That means that the typical performance for a 50 megawatt project would be 102,000 megawatts hour per year. If we assume a 3% annual loss, which we will be avoiding with our T-box high availability algorithm, that means that we would be losing like 3,000 megawatts hour. But if we keep only the horizontal performance, that means that around 1,000 megawatt hour times the PPA would be lost if we don't have a high availability of the tracking system. Apart from that, and regarding the EPC, the construction part of the project, a traditional SCADA would cost around 120 hours times the cost of the commissioning. Okay, because we are assuming like 1 week to start up the rack and 2 weeks to integrate all the tracker signals with a third-party SCADA. With our solution, there is no cost in terms of commissioning works, and we need only 2 days to integrate all the signals from the trackers into the pre-inside SCADA, which means much less than what a traditional SCADA would be. Okay, so thank you very much for your time and for letting me explain on all these features. If you have any question, please.
Oscar, thank you very much for your presentation. So, I can see that there are already a few questions on the Q&A box. So maybe we could jump into the Q&A and answer some of those questions. So, well, there is a question by Sianda Blosse, and this person asks to you, Oscar, if the two-year service is offered remotely or on site. Okay. The service warranty.
So we are offering a 2-year remote service included with the default package. But let's say that it is a cloud-based solution, so there will be no need for site tasks.
Okay. And right, there is another question here, a question by Jose Lago, and he asks, what is the relationship between the PV plant SCADA and the PV substation set SCADA?
So the relationship between the PV plant SCADA and the substation SCADA is something like one can be part of the other one. What Pro Insights is really is a subset of a PV plant SCADA. So if there is any integrator that wants to integrate all the subsystems within a PV plant, they can integrate the tracker as a block, as if it was the substation itself, but only with like considering it is only one piece. There is no need to integrate thousands of signals. There's only one HTML piece that they need to embed in the PV plant SCADA.
Thank you, Oscar. And you know, I have a question for Georgios. Georgios, you know, I know that at Aqua you have built like huge plans, you know, that are like, well, up to like 1 gigawatt. So is there like added complexity as you increase the size of PV plants? They seem to be getting larger and larger. So how does that affect the effectiveness or the management of a SCADA system?
Yeah, good question. Thank you for that. I think as we see more huge projects, this comes along with a huge amount of data management that will impact, first of all, from the human resources point of view. We either will need to rely more on artificial intelligence and bring artificial intelligence within the SCADA systems in order to be able to troubleshoot, let's say, the existing events, but also to be able to foresee, have an understanding of foresee what are potential future failures in our system. The data management itself requires, of course, higher hardware capability, more strong systems in order to be able to cope with this high amount of data. And I think, yeah, this is the main 2 points that we will see us being able to challenge ourselves in the future as the projects are going bigger and bigger. Being able to rely more on computers and artificial intelligence, and being able to have more robust systems that can manage this not only locally but also remotely through centralized data management.
Thank you, Georgios. And Venkata, do you have a view on this? So, you know, how does the fact that PV plants are getting larger and larger affect the management of the plant and, you know, and the application of SCADA systems?
Yeah, Carlos, I think I agree with Georgios what he mentioned. The data that we are going to handle is going to be huge. So, for example, as I mentioned, if you take their project, which is about 1.8 gigawatt peak, see, you have data from around 35,000 of trackers, then you have data from around 3,000 or 6,000 SMB boxes and around 6,000 ARCS. So, and if you put this data and start analyzing, it is going to be very difficult unless otherwise we have some sophisticated software or an artificial intelligence which is throwing the results after analyzing. So this is for 1.8, and if it is going to be a, let us say, new projects like 3 gigawatt, 5 gigawatt, which we are discussing today, the complexity is going to be more. So that way, yes, definitely, we need a sophisticated software which can handle this data.
So, Oscar, as a supplier of this type of equipment, so what's your view on this? So how are you, thinking of adapting to larger scales?
So, our point of view from the tracker supplier perspective is that, and more precisely from the monitoring and control system, is that it is not only about data, but also about control. And it is becoming more and more challenging every time. Nevertheless, that I believe that long-range communications are key in all these scale-up PV plants, but also redundancy in terms of communication too, and in terms of control capabilities. So redundancy is key for all these in order to improve the availability of the tracker. And if as we scale up in the size of the PV plants, the impact of an unavailability is higher. So that means that it is not only about monitoring and data, but also in terms of acting and reacting very fast, very quick after any damage that may happen in any device in the PV plant.
Thank you, Oscar. There is a question here which is it's in the chat box, not in the Q&A, but I think it's a very precise question. I think probably quite relevant, so I will bring it up. Can't see the person's name, but yeah, this person asks, Neha Sahu asks, how can we reduce downtime of inverters by using advanced SCADA systems? So I don't know if either like Georgios or Venkata or anyone on this panel has a view on this. But not all of you at the same time. So if you want to, we can skip to the next question.
I can try to give a very quick answer on that, although it's a very complicated question. I mean, again, in order to understand how you can reduce your downtime of an inverter, of course, you have to treat it differently. Whether you're about a central inverter or a string inverter, where a central inverter, the downtime is a significant event that will cost you a lot of loss of generation. But to do that, you need to have a good monitoring system of all the relevant parameters of your relevant, if you want to say, the relevant statistics of your system and the availability of the inverter themselves. So we have seen, let's say, downtimes of string inverter from 1% to 3% up to 5% of downtime of those inverters in this project. And we have seen, for example, that they are all failing on hot season. And the same more applies on central inverters. I've seen that if you don't have a proper maintenance management in the inverter itself, if you don't take care of the machines, they will face downtime. So a statistical approach, as well as what you said before, an artificial intelligence system that will be able to foresee which are the weak points on your overall project and plan. Mm-hmm. Something that will bring value and reduce the downtime of the inverter itself.
Thank you very much, Georgios, for your answer. So, Venkata, I don't know if you'd like to add to this, or
I just wanted to add what Georgios said. This is the other way will be, you have a lot of data that you are reading from the inverter, and at what instant is this inverter has failed or it has gone downtime. So with that data, if we can bring that all of data and do a preventive maintenance schedule, means before it goes downtime, if this data helping us to do the preventive maintenance, so that we can even reduce the I am not sure. I think.
Yeah. Okay. So I think I lost you for a second there, but I wasn't sure whether it was my connection or yours. So.
Yeah, same here. I think Venkata had the connection.
send me
Okay.
YouTube.
Right. So yeah, I don't know, Venkata, if you'd like to like wrap up, very quickly what you were saying, and then just give it another try.
Yes, yeah. What I'm saying is this preventive maintenance is going to help definitely inverter downtime, which is going to come from again an advanced SCADA.
Okay, thank you. Thank you very much. So there are a couple of questions here actually that are for Oscar. So Fernando Fuentes is asking about, it says, Oscar, when you comment on availability calculations, do you refer to the time-based availability? So the time the tracker has not been in the right position, and or energy-based availability, wherein the time-based availability with the potential insulation lost?
Yeah, it's a good question, very fair question. So we, from the tracker perspective, we are calculating the availability only in terms of time, because we don't have the information from the inverters or from the production itself. So we are calculating the availability based on the available time that the tracker is performing the tracking task.
Okay, thank you. Thank you for that answer. And then there are a couple more questions for you. One of them for you, Oscar, is from Asier Garcia. He asks, regarding Pro Insight, can it be accessed through the internet or only through the local network? And does the system allow for sending commands to the tracker, for example, to go to the safe position?
So Pro Insight is a cloud-based solution. So it can be accessed through the internet, but it can also be accessed from the site, since it is in the cloud. That means that you can control, you can monitor the PV plant from anywhere and at any time, because it is always up and running. And since it is a cloud-based solution, we are not allowing a remote control of the PV plant, because we, for safety reasons, because we don't want anybody remotely without being able to see what happens in the PV plant to control the PV plant.
Right. Thank you. And then there is another question as well for you, Oscar. So they're asking, Julian Anduesa asks, how many plants or how many megawatts does PVH have monitored with this new system?
So right now we have, okay, yeah. PVH has a very wide experience in SCADA systems. We have monitored much more than 1 gigawatt around the globe, and with all this experience, we have designed this system with merging the experience from the specific PV plant monitoring systems with our experience as a tracker controller and manufacturers. With these two key knowledges, we have designed Pro Insights, and we have tested it in several pilot plants, and we are ready to expand this, because it is a very stable solution right now, as for now.
Right. Thank you. Thank you very much, Oscar. And I see, a number of questions are about a number of times Georgios and Venkata have talked about, artificial intelligence and predictive maintenance. So maybe, there is a question here by Keep Koich, and he's asking, how you could use machine learning for output prediction and with your SCADA system. So, in general, any insights into how you're employing these technologies to improve your O&M.
Yeah. Well, the artificial intelligence is basically a machine that you put specific data inputs, and then according to some algorithms, it gives you a prediction of what is going to happen, or it gives you a prediction of what are the possibilities of what is happening. So let's take, for example, that you are monitoring the performance of your PV module string, okay? And there are different failures. For example, there could be a failure because of shading losses, sorry, an underperformance. Underperformance of the string could be because of shading losses, or could be because of hot spots, or could be because of a failed diode string. There are different characteristics. If you do the analysis, and you will see, for example, the performance of that string over the time of a day or over the time of the week, you may find different characteristics in the performance that will indicate you what is the failure. So instead of having someone going outside on the field and inspecting all these three different possible scenarios of what could be a failure, a machine could do that for you. That's what artificial intelligence is about. Now, how is this being done? As I said, there are specific softwares out there, specific companies that are dealing with where they're getting the inputs from the SCADA system. As long as the data is available, the resolution of the data is such that can be used for this, for the purpose of feeding an artificial intelligence machine that will give you the necessary output of what you are looking for. You are looking for making systematic analysis over your problems, over your already facing problems, or whether you are for a predictive analysis of what could be problems that you may face in the future. For example, for an inverter, if an inverter is facing derating to high temperature, or if you see, for example, with the artificial intelligence, as a very specific pattern of inverters' internal components rising temperature, this could be an indication of triggering maintenance, or it could be an indication for you to trigger some more thorough investigation of why this is happening. These are the things that today you rely to human intervention on to the operator in order to be able and experienced enough to do it. And this is where the artificial intelligence will come into play, and will give you the benefit to be able to predict and catch in advance a problem before it becomes a disaster.
Brilliant. Thank you very much, Georgios. And we have 3 minutes left. So I don't know, Venkata, if you'd like to add to this, or if we should just go to our closing statements.
Yeah, let us move on to next question. I think, yeah, Georgios has explained very.
So, well, I think, we have answered most questions. There are, a couple of questions that are specifically related to PVH systems, but we'll send those to you, Oscar, and you can, reply by email and get in touch. So, in your, I just wanted to ask you to, if you want to give kind of like a closing statement before we all leave. We only have a couple of minutes left. So, anything you'd like to tell the audience, and let's start with Venkata. So any message for the audience before we leave?
Yeah, I think I would suggest to have or to handle the data. Of course, we need a sophisticated software SCADA. That way, I think PVH has already come up with a Pro Insights, which is doing really are addressing the key challenge that we have mentioned. So thanks to PVH, and that's all from my side. And thank you everyone for attending this webinar.
Thank you very much, Venkata. Georgios, any parting words for the audience?
I just want to say thank you for all the participants. I think that at some point we have reached more than 85 participants. I hope we have been helpful from our side as well, in order to share some of our knowledge around the key challenges we are all facing today on developing those projects with our respectful stakeholders. And thank you everyone.
Thank you very much, Georgios, for being here with us today. And Oscar, so any parting words for the audience?
I would like to thank ATI Insights for the opportunity to share all this with the audience, and also send a message of like we are experiencing as we said, a scale-up process and scale-up opportunities for all the PV plants. That leads us to many more challenges that only data and smart monitoring systems can allow our customers and our users to get the insights, the proper insights from all these data, and to control and manage properly of the PV plants and the huge amount of trackers and data that is going to be generated in the following years.
Thank you very much, Oscar. So, well, I'd like to thank Oscar, Venkata, and Georgios for the presentations. I think it's been very helpful. And I'd like to thank everyone who's been in the audience with us. So if you like this type of content, you can come to our website, which is my, as in the word, my.atainsights.com. And actually, we'll send you an email with the recording and the slides of this webinar. But in case that you don't get it, well, first check your spam folder in like 2 or 3 days. And also, even if you don't get it there, you can still access it through our webpage. So thank you very much for being with us today, and until next time.